All right, I don't remember if it was this class or the other class. I've been getting lots of text messages asking for help. Totally cool. But is anybody stuck on any of the most recent homework other than the fact that I believe one of the assignments, the instructions weren't posted until today? That would be a sticking point, right? But if you have looked at the homework, anybody stuck? Anybody stuck? Anybody stuck? Anybody need hints about what we're doing? Yes? Just a second. I am 90% deaf, so I'm getting close to you. Okay, so. Okay. So in one of our questions, if I correctly recall, we're rolling dice to see whether they match. No, whether they roll a 12, right? Okay, so we had a sample loop in our notes, but it wasn't quite the same because our sample loop ran a certain amount of time. And this loop does not run a certain amount of time. It keeps running until the condition is met. So that's what's known as an indeterminate loop. We'll make some notes here. So what we had last time was something that looked like this. We had two ways of doing it. And we have to import random in order to get things cooking. And then our first one, the example that we had, looks something like this. Count how many times we roll doubles. I think that was it. Not doubles. So we needed a counter. We had to initialize the counter to 0, and then we went into a loop rolling 2 dice. And then we would check to see if those dice matched. Now this isn't a homework assignment, but it's instructive. So we are going to roll the dice a certain number of times. I think in our example we made it fancier with, a constant to set the number of times we were going to roll it. Why not? Right. What? Num underscore rolls is equal to, let's roll the die 20 times. And we need to initialize our accumulator. No, not total. Our count. How many times we've rolled doubles. In fact, we could call it doubles, right? How many times we have rolled doubles. Now this one is going to roll 20 times, meaning that it's a determinate loop. Determinate means we know in advance, or the program knows in advance, how many times it's supposed to repeat. So I'm going to make a little rule down here. Determinate looped, we know in advance how many items, or how many times to run. And for that we use a for loop. Alrighty, so we're going to use a for loop. And we're going to iterate a counter, which I could just call I, or X, whatever our favorite single letter variable name is, up to 20. For X in range 20. Now we might think that counts from 1 to 20, but it really counts from, we might think it goes 1 to 20, but it really goes 0 to 19, which is 20 items, right? It's just that it always stops 1 before this number. We can make it do 1, comma, okay, see, and here I had a variable called num rolls, and so that 20 should really be num rolls. My mistake. Now we need 2 dice to roll, D1 and D2. D1 equals random dot rand int parentheses. We want to start at 1 and we want to go up to 6, unless we felt like changing it, right? Like, we're rolling 2 10-sided dice or 2 20-sided dice or something like that. But this will do. And then just copy and paste that and make it D2 equals, right? Same thing. We're just rolling 2 dice. Now we need to check to see if they're equal. If D1 equals D2, colon. If D1 equals D2, colon. Then we have a match, so we're going to increment our counter. Count plus equals 1, or count equals count plus 1. I'm going to put an end if comment here, although it's not necessary. And I'm going to put an end for comment, even though it's not necessary, just because I like to keep track of things. And now we could count, or we could calculate, or our sample code calculated what the percentage. How many times did we roll doubles? What was the percentage of times? Well, the number of times we did it is count. The total number of times is numerals, right? Because we looped through it 20 times. And like if count is 3, how do you calculate percentage? 3 divided by 20 times 100. So we can do that. Average, AVG equals count slash num underscore rolls times 100 to make it a percent, right? If it rolled it 10 out of 20 times, 10 divided by 20 is 0.5, and we want to make it say 50%. And we could print out our answer. Print %D doubles average. I guess it's not an average. That's a percent. Excuse me. I'm going to change that AVG to the word percent. And so percent F, because it's going to be a fractional number, percent. Or how about just a percent? Yeah, I'm going to use the word percent. And then after the end quote, we need to fill in those placeholders. We need to fill in those %Ds, so I'm going to use a percent sign. And then we need open parentheses, close parentheses, and inside those parentheses we need to fill in the variables that are going to print %D and %F. %D meaning it's an integer, because as a matter of fact, count is an integer. So count, comma, and then this one gets filled up with the percent variable. So we're just using a formatted print statement to make it look nice. And I bet we come back in and we modify this %F to make it look prettier. Are we on G? Looks like we're on G. Alrighty. I'm going to run it. Hope I don't have any syntax errors. It'd be nicer if I printed out each roll, right? Maybe I'll make that change. That time we rolled 2 doubles. That time we rolled 6 doubles. And so on. Okay, 7 doubles. Now, if it always came out 0, we would be really curious as to why it was coming out 0. We would want to see the numbers as they were being generated. So why don't we print them out? So up above our if statement, print parentheses, and we're going to use 2 placeholders just to print out the values, right? So percent, D1 equals %D, comma, D2 equals %D. Why am I using %D? Because D is what you use for whole numbers, and F is what you use for floating point numbers. And so again, since we have placeholders, we need to put a percent sign and then parentheses. So percent, parentheses, 2 close parentheses, and we're going to fill them in with D1, comma, D2. Now we just get to see what we're rolling, right? Make ourselves, pretty sure that it's working. It'd be even niftier if we flagged the doubles, right? If we printed an asterisk showing that they were, the same or not, but we're not going to do that this time. We may have done that in the last one. All right. Howsoever, our homework assignment was not meant to count the number. It was supposed to count the number of rolls it took to get to a 12. But this time, I don't want to give you the solution for the homework. I want you to have to sweat it just a little bit. So instead of doing the homework exactly, instead we're just going to count the number of times it takes to roll a double. Meaning that we can steal these 2 lines of code, these 3 lines of code, these 4 lines of code, and we're going to repeat them. But it's going to be a while loop. So we're going to need a counter. How many rolls have we made? Rolls is equal to 0. And then we're going to need a while loop, while D1 not equals D2. Well, we don't know what D1 and D2 are yet. So maybe I'm just going to set them, yeah, this is getting a little bit weird. Let me look to see how I suggested to, well, I didn't. Let me see how I suggested to do this to somebody. It was more elegant. All right, that's how we did it. Okay, so nope, this is no wonder it's coming out different, because the homework is to see if they equal 12, and that was easy to code. In this case, we're checking to see if if they match. Slightly different logic. So why don't we just do this? This is not perfect, but it'll work. Match is equal to false. We don't have a match yet. And we're going to need a counter. Where'd my counter go? Didn't I type in rolls? Did I delete it? Rolls is equal to 0. Now we're going to do while match equals false, which is not strictly necessary. That's not the syntax you need to do. While match equals false, colon. That means we don't have a match yet. Now we're going to paste this stuff. We need these 4 lines of code. No reason to recreate the wheel. Boom, like that. And so, if D1 equals D2, we have a match. So match equals capital T true. And then end if, and we need to increase the counter no matter what. So rolls plus equals 1. And then end while. To get this to work, to be the homework, I'm giving you like 90% of the homework. All you're going to have to do is change that if statement. That's all I'm going to say about that. Alrighty. And then we're going to print a message. Print, parentheses, quote, it took %d rolls to get a match. You'll change your answer, right? I mean, you'll change your print statement as well. So end quote, %, and we need to fill in that rolls, so rolls. We didn't have to put the parentheses if there's only one value. If you have more than one value, more than one placeholder, that's when you have to stick all your parameters inside parentheses. Now that might even work. Let's find out. Yeah, it took 4 rolls to get a match. Instead, you're going to be checking to see if it equals 12. And I'm sure that we've got syntax error, so let me wander around. Okay, that time it took 7. All right, this is a silly idea, but how long would it take to roll 3 dice and have them all match? We're going to make that change, and then we'll probably undo it because it doesn't match the homework exactly. But I am curious, right? Nah, we're not going to do that. Let me forget that. But you could probably imagine how we would do it. You would just roll a 3rd die, and then your statement would say if D1 equals D2 and D2 equals D3. Then we'd have to change our print statement as well. And since it was requiring 3 changes, I decided just to, cancel that little extra stuff. So compound Boolean expressions. Let me tab this over as it should be. All right, so sometimes a course of action must be taken if two conditions is true. The user types in a number and the number is either too large or too small. We could handle that with if-elif. If the number is greater than 100, print error, must be between 100 and 0. Elif number is less than 0, print grade must be between 100 and 0. Otherwise, print the result. If you have multiple results, and I'm going to use a fancy term that I doubt the book uses, in an if cascade. If you have multiple actions that are the same action triggered by multiple ifs, then you can fix that by doing an or. Oh, good point. Yeah, I did. What do you know? All right. So, we don't need to check to see if it's greater than 100, do my thing, elif number is less than 0, do my thing, when we could do this. If the number is greater than 100 or the number is less than 0, do my thing. So there's two basic rules of thumb about when to use and or. If you have this set up, if A, do thing 1, elif B, do thing 1, else, do thing 1, 2, right? And I'm going to delete the else, I guess. Nah, why not leave it? Nah, delete it. Okay. Then you could replace that with an and. So kind of stacked ifs. If, elif, elif, elif. You could do if A and B, colon, do thing 1. Why does that work? Excuse me, because I used the wrong operator. There. If A or B, right? Because if that's true, do that. Or if that's true, do that. Now this wouldn't work if it was thing 1 and then thing 2, right? This only works if the same action is being triggered by multiple results. If the same action is being triggered by multiple conditions, you can chain them together with an or. Then we'll make that a little comment. If if the same action is triggered by multiple conditions, use an or to simplify the logic. So when do you use and? If it looks like this, if A, or let's use other variables, if C, colon, and then over here, if D, colon, then do thing 2. Right? If C is true, all right, now we're going to check see if D is true. If D is true, do thing 2. So thing 2 only gets done when both of those are true. In other words, an and. So, if you have nested ifs, see if you can replace them with an and. So, instead of if C, tab over if D, tab over do thing 2, we can do if C and D, colon, do thing 2. Now I hope you all realize, I hope this is pretty clear, that A is just an expression, right? If X is less than 10, L if X is greater than 20, right? And then we could combine those in the same thing. Similarly down here, if age is greater than 13 and citizenship equals yes, then they can vote. So we could put them both in the same if statement. If age is, greater than equal to 18 and citizenship equals yes. So when I'm using letters there, these would actually be Boolean expressions, unless there were variables that have been set previously. And so that's what that page is showing us. This condition triggers action 1, else this condition triggers the same action, else do something completely different. So we reworded it. if condition 1 or condition 2, then do our thing, else do the completely different thing. So and or. I think I've shown this logic. Maybe not. In order for and to be true, both operands of the and keyword have to be true. Operands just being the thing on either side of it. The expressions on either side of it. So the only time and is true is if both sides of it are true. I am hungry and I have money, go out and eat. If I don't have money, I'm not going to go out and eat. If I'm not hungry, I'm not going to go out. So that's the only time when I both have money and I'm hungry. Now, or is always true unless both conditions are false. If I am sick or I am tired, stay home. So I get to stay home if I'm sick and tired. I get to stay home if I'm sick or tired. I get to stay home if I'm not sick but I am tired. But I have to go to work if I'm not sick and I'm not tired. And then lastly, the not refers to the truthiness of it. If A is true, then not A is false. If you look at this, this looks in a way like a multiplication table if you pretend that the trues are 1s and the falses are 0. Right? 0 times 0 is 0. 0 times 1 is 0. 1 times 0 is 0. 1 times 1. All right, I finally got something. True. Or you could also do the same thing, but it's not times, it's plus. 0 plus 0 is 0. Remember, we're using 0 for false and 1 for true. 0 plus 1 is 1. 1 plus 0 is 1. 1 plus 1 is, okay, it's 2, but this is a universe of math. Boolean math only has 2 possible values, 0 and non-zero. So 1 plus 1 is 1. Now that has an implication. What operator has higher precedence than the other? Multiplication or addition? Multiplication. And is like multiplication. So if you write an expression, the and will get done first. Now again, I'm just going to use letters rather than write out a whole, x greater than 10 and y is greater than whatever. So, and is akin is logical multiplication. And if you ever take a logic course, you'll see that, right? A and B will be expressed just like that. And if you had A and B or C and D, you'll use the plus signs to match them up. Now, I don't care about that, but let's do, if and is logical multiplication, then or is logical addition. So, and has higher operator precedence than or. So if we add this, if A and B or C and D, we'd have to figure out which of these are true and which are false, and in order to figure that out, we don't just go left to right, just like we don't just go left to right when you're doing an expression that mixes multiplication and addition. Instead, you do the ands first. You figure out A and B. Is that going to be a true or false? Well, it depends on what A and B are. Then you look for the next and. You figure out C and D. All right, great. Now that you have those two values, then you can OR them together. So that becomes if A and B or C and D. That's how it's translated. We don't have to put the parentheses there, because that's how it's going to be translated anyways. I just put those for clarity. Because and has higher precedence. You feel like putting parentheses in there to force the issue? Totally fine. Now, if you really wanted B or C to be done first, you'd better put those in parentheses. I'm going to write this and then erase it. But if you wanted B or C to be done first, you'd have to do this. You'd have to force the issue, just like you do in math. Right. Then this would be evaluated. Once that is evaluated, then and only then would it evaluate that and then that and. Here's something you cannot do. If x equals 10 or 11. Looks great, but you can't do it because each side of OR has to be a Boolean expression. That is a Boolean expression. It's either true or false, but 11 is not a Boolean expression, right? So if you had a true here and then you tried to OR it with a number, that's crazy talk. It couldn't do it. So this is wrong. You would have to do it like this. If x equals 10 or x equals 11, like that. That would be the correct way to do it. Another thing that people wish they could do is this. If 5 is greater than equal to x is greater than equal to 10. They want to write a range between 5 and 10. Makes sense in algebra. Looked good in high school. We can't do that. Instead, we have to do if 5 is greater than or equal to x and x greater than or equal to 10. That's how we do that. That makes sense? I'm seeing some stunned looks out there. Probably because the idea of using variables to mean true or false is a little bit foreign. So we will have to come back to that topic at some point. Just remember that we could replace these with expressions. Like if we had this, you know, we could do if, whoopsie, come back. You don't have to type this. If x is greater than 10 and x is less than 20, or b is greater than 10 and b is less than 20, right? Those letters just represent little miniature Boolean expressions. I just picked that completely arbitrary. And what would this do? If x is between the values of 11 and 19, or b is between the values of 11 and 19, it would trigger the action. We should probably have more homework on that, or I should make a worksheet where you have to figure out the ands and the ors based on whether the values are true and false. I've done that in the past. Consider it. And then there's not. So what if we had this? If temperature is less than 32, print freezing. All right. What if we wanted to reverse the logic and print not freezing? Two ways to do that. If temperature is greater than or equal to 32, print not freeze. That's one way to do it. Or you could do if not temperature less than 32, print not freeze. Both do the same thing, right? Here we flipped the sign in order to do the opposite. Here we didn't flip the sign, we just stuck a not in front of it. Now by the time your expression has a couple of not keywords in it, it becomes much more difficult to read. I always try to write my code in such a way that there is no not keyword in it, just because our brain has to kind of go through somersaults. The computer doesn't care, but our brain does. So I would have chosen this way, but this works just as well. The only thing you have to remember is that the opposite of less than is not greater than. The opposite of less than is greater than equal to. Otherwise, if the temperature is exactly 32, it would not print freeze there. And if the temperature was exactly 32, it would... Am I lying? Oh. That's because this is written correctly, right? If I didn't remember, I had to use greater than or equal to. If the temperature was 32, would it print freeze? 32 is not less than 32, so it's not going to print freeze. And then we tried to flip it. If temperature is greater than 32, is it going to print freeze? Well, 32 is not greater than 32, so it's not going to print either one. So in that case, if temperature was equal to our boundary, we're not going to get any output. So if you have a less than, the opposite is greater than or equal to. If you have greater than, the opposite is less than or equal to. So less than, opposite is greater than, equal to. Greater than, less than, or equal is opposites. And then equal, equal, what's the opposite of equal, equal? Not equal. So if you see that, that means not equal. And so if I say not equal, I'm probably going to do that rather than saying not equal like that, right? That symbol means not. And in some languages, there is no not keyword. If we were going to do this in one of those languages, we would replace that with an exclamation point. And Python likes the whole entire keyword.
Can you use nots on while loops and stuff as well?
Right. While, here we did this. While match is not equal to false, while match equals false, we could do this. While match not equal to true. If your brain works like that, that's totally cool, right? While match is not equal to true, keep going. Eventually match will be set to true and the loop is no longer true and it's going to fall out. It's a very good question. This one doesn't have an equal sign. Well, I guess it does. But it wouldn't make any sense to do that, right? Okay, here, this is moronic. You could word it like that. But then you're getting into a double negative, right? I ain't not going to the store. What does that mean? All right, yeah, we're going to undo that. Two negatives make a positive, so that would be a positive. So when you're testing, make sure that all possible branches, all possible alternatives have been exercised. Programmers always write things and then they test them to see if they work. You also need to test them to see if they break. Like if I had tested my code here to see if it worked, right there, I might have typed in a temperature of 100 and it would say it wasn't freezing. Cool deal. I might run it a second time with a temperature of 0 and it would say it was freezing. I'd feel real good about it and I'd stop testing. No, you also have to test your edge cases. The edge cases are the numbers that are being checked for specifically to make sure that they behave the way you want. If I hadn't worded that one correctly, then if the temperature was 32, it wouldn't have printed anything, and I'd have to go back and figure out why. So test all possible branches. You want to trigger all possible branches. I want to see that one trigger at some point, that one trigger at some point, that one trigger at some point. So you should test boundary cases in the above example 32. I did not mean to launch Java. So while, conditional iteration. Keep repeating while that case is true, also known as a determinate loop. Here's our example. Keep accepting values until the user enters a sentinel that terminates the input. Pretty sure we've done this before. Like this. X equals, I'm going to write it in short form, float, parentheses, input, parentheses, quote, enter a number to double. End quote, in parentheses, in parentheses. Why did I have two closing parentheses? Because I have two opening parentheses. And then I could do this. While x not equal to -1, I should have told them that typing in -1 will kill it. So I'm going to have to go and modify this string up here. Colon, let's double it. Print x times 2. Good enough. End while. So we're going to keep typing in numbers until they type in -1. I better warn them that that's how you quit. Or -1 to quit. Which makes -1 the sentinel value. -1 is the special value that causes the loop to stop. So it is the sentinel value. Some textbooks call it a sentry value. Same thing. It's a special value that's not valid data. Now really, -1 looks like valid data to me, right? You know, but we just chose it arbitrarily to illustrate the point. All right. Now that way down here where I can't see it, it's asking me to enter some numbers. Enter a number to double, 3. And woo-hoo-hoo, what did I do wrong? Why is it in an infinite loop?
You didn't tell it to break.
Right, I could make it break, but that's not really going to fix it. Like if I just took a break here,
Just kick out.
then it'd kick out of the loop as soon as it did it one time, right? Print out, okay, that was 10 and then done. My goal was to let it repeat. So I do need to put something there, but what do I need to do there? Yeah, we're not going to use else because we don't have an if. Check where we're getting our input. Right? We're getting our input once, and we want to get it over and over and over. So where else do we need to get some input?
Right above the print statement.
Or right below
print
it.
statement.
Right. So I'm going to grab that, and I'm going to paste it here. And you're right. We could rewrite this so that it used a while and a break. A while true and a break. And that's actually my preferred way. This is the fundamentals of programming approved way where you have what's known as a priming read, and then you repeat that code. I hate repeating code. So if I was going to do that my own favorite way, and the textbook does show this, thankfully, you can use a while true loop. But let's put a comment here. While is used for indeterminate loops. When you don't know how many times it's going to run. We don't know if the user is going to want to double one number or 0 numbers or a billion numbers. So here we go. While true. In other words, just keep repeating forever. But we're going to have a break statement so it doesn't really repeat forever. Now I'm going to copy that statement rather than type it in again. Boom, like that. And then I'm going to print x times 2. But if they typed in -1, we don't want to print out x times 2. So we're going to put a break statement right here. If x equals -1, again, that's our century value, then we're going to break. And now we either could put the word else there, but we don't have to because once we've broken, then there's no way to reach that. All right, so that loop does the same thing as this. We eliminated the priming read. I feel good about that, at the expense of having an extra if statement down in the loop. We didn't have an if here, we had an if here. Both of these totally work. This is the way my brain works, so this is the way I would do it if I ever, that's how I do century values, is typically like that. You get your input, then you check to see if you've hit the century. If you have, then you break. Really, you should only put one break in a loop. If your loop is getting so complicated that you have multiple breaks, then there's probably time. It's probably time to rethink your logic a little bit. Just like if you have multiple nots inside of a expression, it's harder to think about. If you have 200 lines of code and you have a break statement hidden somewhere, line 50 and another one, at line 175 or whatever, it's hard to follow the logic. Generally, there should only be one way out of a loop. That's not strictly necessary, true. But right here, there's only one way out of the loop. If x finally equals -1, it stops. And here, there's only one way out of the loop. If it hits the break statement, it stops. The book shows an example of that. Right here. If only, I complain about this every time. Like that. Come on, go down. Alrighty. Same thing. While true. Keep repeating forever until we hit a break. Data is equal to enter a number or just press enter to quit. In this case, just pressing enter is our sentinel value. And so they type in a number. Maybe, or maybe they just hit enter. If data equals empty, because they just hit enter, then we break. Now here they left out the else, right? You don't have to put an else in. like I said, it's optional because if you break, then you know this stuff's not going to happen. That takes the place of the else keyword. But if they broke out, we're not going to do these things. If they didn't break out, then we have a number. So we convert the number from a float, we store it in there, and then we add it to our sum. So that's what the break statement does. The break statement kicks it out of the loop. There's a variant keyword called continue. And have we talked about how continue is different than breaks? Okay. Break kicks it out of the loop. It goes to the bottom. Continue causes it to reiterate. Means it goes back up to the top immediately. Like this. We're just going to set up some little counter. It's going to be determinate because I want it to count through a specific range. So for x in range, count up to 10 for me. X in range, parentheses, 10 in parentheses, colon. And now we're going to do something. If x is equal to 7, we hate 7. So we're going to break once it hits 7. Now that's stupid, right? We should have just put, 8, or we should have just put 7 there. But this is just to prove a point. If x equals 5, colon, then continue. If neither one of those things are true, then print x. How about we make the print statement look a little bit different? So I'm going to put print x equals, end quote, comma. Just so I'm not getting a continuous series of numbers without any context. And then I'm going to put an end for here. Although I didn't do that on the while loop up above, I would have if I thought of it. All right. So what's going on here? Enter a number or -1 to quit. All right, 1, 2, 3, 4, -1. That loop works. Now it's asking the same thing, right? Because I rewrote it as a while true. 10, 20, 30, -1. And now it printed 0, 1, 2, 3, 4, 6. We got some weird behavior. It was supposed to count up, 0 to 9 because of the range. But instead, right, it printed 0. And then it looped again with x being 1. Nothing special happened because it didn't ever equal 7 or 5. It looped again with x equals 2. It looped again with x equals 3, x equals 4, and now that x is equal to 5, something special happened. Well, 5 is not equal to 7, so it did not break. 5 is equal to 5, so it continues, meaning it ran back up to the top of the loop. It did not do the print. So it did not print out 5. So what could you use that for? You could use that to rule out some error state. Force it to reiterate if they enter a bad value. So while true, colon. Let's get some input. X equals float, parentheses, int, wait. Float, parentheses, input, parentheses, quote. Do I need to?
I was just to say we're almost out of time.
Yes, we are. Yes, we are. We have 7 minutes left. Enter number. Parentheses, quote, parentheses. But if x is 0, it's going to be an error state because we're going to try to divide by x. If x is equal to 0, colon, print must not be 0. Would have been nice if we told them that in advance. And then we're going to continue. In other words, you better give me some good data. If it's non-zero, it's okay. So print parentheses 1 over x. Now this thing doesn't even have a way to get out, but this is the last time through anyways. So, -1 to get out of that loop, -1 to get out of that loop. Enter a number. 2, 3, 1 over 3, 4, 1 over 4, 5. If I hit 0, it says must not be 0. So that continue statement stopped it from getting to this point. Break kicks it out. But continue causes it to immediately jump back up and reevaluate, skipping the rest. Similar ideas, but break kicks it all the way out, skips everything from that point to here, and continue skips everything from that point
and goes back up to the top.